And we're live. Yes. Excellent. With 3 people. Yes. I'm assuming that number is going to be increasing soon as some of y'all seniors are going to be waking up. It's going to be nice. We'll figure it out. We'll figure that junk out. I don't know. That's down to 2 people. Wonderful. That went back up to 3. So yeah, I'll give you guys a few minutes to kind of meander into the live stream before I begin what I want to do today. What I want to do today is going to be similar. As a heads up, it's going to be similar to what we did on Wednesday. I want to start by reviewing certain key concepts in regards to the final exam that you guys will be taking for me. Yes, that's partially what I want to start with. I wanted to spread it out a bit because it's just such a wide swath of information dating back to September. I wanted to do a little bit on Wednesday, a little bit today, and then next week is just going to be full on review. I'm going to have certain online things that we can kind of play around with as we're reviewing. We'll get that thing done. It'd be great. And then, of course, supposedly, the week of the 25th, you guys will be back. Supposedly the week of the 25th, you guys will be back in the classroom. I say supposedly, but, we'll figure that out. Yeah. See, now I got 4 people. Something like that. I know, where are people? Yes, and I do appreciate the comments so I can keep an accurate record of attendance and whatnot. It's incredibly helpful as people are now strolling in. Whoa, that's a bunch of hearts. No, wait, those are hearts? What are those? What the heck are those? Are those empanadas? Oh, it's a handshake. That's so weird. Sorry, maybe I have empanadas on the brain. You guys ever have empanadas? Or just, I don't know. Depending on what they have, beef or chicken. They're really good. But it's a handshake. I apologize for that. So, yeah. For the record, and again, I really do hope that you guys are actually in the classroom during the week of the 25th when we take our final exam. I mean, it would be the last time I would see you guys as a class. And I'm waiting for them to show up, but I did order trophies for our fantasy football champions. Just so you know. I don't know. But anyway. So, just giving people another minute or so again, because it's like 11 people are in the chat, but I know there's a lot more there to it. So, yeah. Well, I'm just saying, Chris, I have the trophy. I mean, I'm sorry, I ordered the house before the end of next week, and you guys will still be on quarantine next week. So it just works out that I would have it for the final exam, but it depends on whether or not you guys are actually in school or still quarantining during the week of the 25th. So who the heck knows? Anyway, so goal for today. In a few moments, I'm going to begin reviewing some certain key concepts that I've outlined for you. I want to review for that final exam. Now, I don't want to review the entire class period because I also want to give you an opportunity to continue working on said project. I went through all of the I'll talk about that in a minute. I went through your project mid checks. Not everybody did it, but the ones that did do it, I was very happy with what I saw. Now, obviously, I'm very interested in your opinions, of course, because the one section is like general thoughts and discussion on the project. But yeah, and of course, I did post the Google Classroom assignment for the project and the due date and the rubric, the adjusted rubric, because obviously we can't do in-person presentations. Now, in terms of the marking period, Aiden, the marking period technically ends, I believe, on Thursday, January 28th. I'm just kind of double checking that right now. Yes, Thursday, January 28th. I've been hearing conflicting reports about the 29th. I've heard that, I've heard that, oh, they're going to extend it one more day or blah, 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 blah. I'm like, let's assume it's the 28th, Thursday, the 28th, which is the last day of midterms. And we'll figure that junk out. Now, grades, obviously, for teachers, they'd have a little bit of time to get those grades in. But that would be the official last day of the marking period. And then the 29th should be the first day of the third marking period. So we'll figure that junk out. So Matt prefers beef empanadas. Chicken, beef, anybody? Oh, goodness. Anyway, so in terms of the review, what I would like to do, if you do not already have them out, I'm going to need those notebooks out and open. So I have picked out a small handful of problems that I would like to do with you. Now, if you do have any specific questions, I do have the chat open on my phone over here, so I can take a look at what specific clarification you may end up needing. Let's see here. Ooh. Okay. So let's start with something like this. Here we go. Zoom it out a little. Okay. Now I'll kind of focus in on what you need to write down. Keep in mind, certain formulas will be provided to you, but how to use them in the proper route that you would take, obviously, it depends. You need to know how to do that stuff. A football player is running an out route by running 10 yards to the left, then turning 90 degrees and running 30 yards down the field and stopping. If the player had just ran a flat route instead and stopped at the same spot, how many yards would the player have run during that flat route? Now, we did a bunch of problems with angles and triangles and things of that nature. Sometimes you would need the Pythagorean theorem. Sometimes you would need SOHCAHTOA. It really depended upon what the question gave you. It really depended on what the question gave you. This particular question, well, I'm not really going to know exactly what to do with it until I draw the thing out, which is what I suggest that you do as well. Draw the thing out. So, get my red pen. A football player runs an out route by running 10 yards to the left. So let's just say this is the starting point. And they run 10 yards to the left. 10 yards. Okay. Then turning 90 degrees and running 30 yards down the field and stopping. 30 yards, 90 degrees. Now, it seems to me like we got a Pythagorean problem on our hands. Yeah. And if you happen to remember that, well, this flat route is just going straight there. And if you happen to remember Pythagorean theorem, which you had to do on a few of those football assessments that I had for you guys, it's just a squared plus b squared equals c squared, as you've done in geometry 100 times over. Now be careful with your calculator. Be careful with how you do this particular problem. Let me flip this thing to my calculator. Japan. Let's see. 30 squared plus 10 squared. Boom. 1,000 square root of 1,000. Oh, gets me a decimal. I know that glare. I'm going to try and move it over a little bit when I flip back to my little paper. But let me write down this answer. There we go. So the work that I have on the calculator, that obviously is needed to get this particular problem done. Just please make sure that you're typing things in correctly. But in terms of what I wrote down on paper, move that over a bit. See, because I can see the glare from where I'm sitting. Move it over a little more. There we go. Almost got it. So I kind of angled the glare in between the problem right there. But yeah, depending on the question that they're asking, you may have to draw a different type of triangle or use a different method to get this particular problem done. Now, in the next problem that I have for you, will definitely kind of test that idea of like, oh, wait, what do I have to do? Kind of thing. Because they're not all just going to be Pythagorean problems. I mean, one interesting question here is, well, the guy ran 10 yards left and 30 yards up. I mean, that's 40 total yards that he ran with a cut in between. If he had just run straight there, it's 31.62 yards. Obviously, depending on the strategy that's being played. I mean, if he can outrun the defender, why not just run straight there? If he's just trying to juke out the player, then, of course, make the cut, get around him. Go Ravens. Anyway, number 7. You are given the opportunity to shoot a hockey ball. And yes, hockey ball, because you're on a basketball court. Hockey ball across a basketball court in the gym to try and win a bagel breakfast for your homeroom. The basketball court is 94 feet long. And the hockey goal is 6 feet wide. Determine the, quote, angle of error allowed for the shot. Note that angle and error includes both the left and right angle. See, now with this problem, again, I'm not entirely sure what I have to do with it just yet. My best course of action, draw a picture and see where it goes from there. Now, I'm not going to draw this to scale, simply because I don't feel like drawing like such a long picture. So instead, I'm going to draw something like this. Let's say that, I can't see it. There you go. Let's say that that is the hockey ball. I have to shoot this thing 94 feet until it goes through the goal. And again, not drawing this thing to scale. Let's say that this is the hockey goal right here. Now it's 6 feet wide. Yes, I get that. And they're talking about angle of error, meaning you could miss a little bit to the left and a little bit to the right. There's missing to the left. There's missing to the right. This is 94 feet. And because dead center on the hockey net is halfway, this has got to be 3 feet right there. And I got a 90-degree angle. Now, could this be a Pythagorean problem? Unfortunately, no. The Pythagorean theorem would just get you the hypotenuse on that triangle. That's all that it would get you. What the question is asking is they want to know the angle of error, meaning how many degrees to the left or to the right are you allowed to miss by and still make the shot? We need to know this angle right here. This is theta. I'll zoom in on that picture a little bit more. That's theta. We need to know what that angle is. So the way that I'm going to go about doing that, it seems like I may need a SOHCAHTOA situation going on here. SOHCAHTOA. Let's see. SOHCAHTOA. From theta, I have the opposite being 3. And from theta, I have the adjacent being 94. the hypotenuse is always the longest side. Okay. So it looks like tangent. Let's set up tangent. Tan of theta equals opposite over adjacent. If I can figure that out, that gives me the angle. And again, that angle would be reflected on the other side as well. So whatever the angle is, that actually is the answer. That would be like, oh, if I'm hitting straight, if I'm hitting the ball, the hockey ball, perfectly straight, that's 0 degree error. But if I miss a little bit to the left, how much am I allowed to miss by? If I miss a little bit to the right, how much am I allowed to miss by? So let's take a look. I got to go to my calculator. Make sure that you change the mode in your calculator to degrees. You need to have this thing in degrees. I emphasize that a lot. Going back here, if I'm going to solve that particular problem, let me type out what I would actually calculate. And then I want to write it down. Notice what I just used right there. I used what is known as the inverse tangent, or arctangent, if you would. But I used the inverse tangent, which you get by hitting second tan in order to get that theta by itself. I did arctan of the 3 over 94. And by doing that on the problem, it gets theta, the angle, by itself. Again, I'm set to degrees. There we go. I'm going to flip over to what I'm writing in a moment. Let me just write down that answer. Theta equals 1.83 degrees. There we go. Now let me flip back. There we go. The way that this problem should be done, move this over a bit. There we go. The way that this problem should be calculated, there we go, is you take the inverse tangent of 3 over 94. The general idea being that if you take the inverse tangent of a tangent, they cancel each other out, but whatever you do to one side, you have to do to the other, allowing you to get that theta by itself. You can miss approximately 1.83 degrees to the left, or you can miss approximately 1.83 degrees to the right. Nice. Again, depending on the question, a lot of these questions may end up having you draw like, squares and triangles and things of that nature. But depending on what the question is asking, you may have to perform a different task. So this is just, again, the general idea that, well, angle of error. Let's talk about Darren Sproles. If Darren Sproles returns a punt for a touchdown from his team's 20-yard line in 9 seconds, how fast is he running? And more specifically, I actually want to convert the answer to miles per hour. I'm going to put in miles per hour. Now, keep in mind, he's running from his team's 20-yard line, which means he's returning the ball somewhere from here. Now, I don't know if he's running in a straight line. Obviously, some of these guys, they run in, zigzag patterns just to get around defenders. But the general assumption is he has to run 80 yards. He has to run back 80 yards. And he does it in 9 seconds. Let's write something at the bottom here. He has to run 80 yards in 9 seconds. Now, the thing is, again, I could just simplify that, do 80 divided by 9 and get yards per second. But I want miles per hour. I don't know if y'all caught it this past weekend. Ravens, Titans. Lamar Jackson ran a touchdown like almost 50-yard QB run. But there are two crazy things about that run. Number one, there was this picture taken of him standing on the 20-yard line in the middle of that run, and there were 3 defenders closing in on him. And somehow, they were just like, he still scored from this position. There were 3 defenders that had a clear shot at him. They didn't do it. Second, the dude cracked over 20 miles an hour, which is insane for a quarterback. Insane. There are not that many quarterbacks. There are a few that could run that fast in that short amount of time. I love it so much. Anyway, back to this. Go Ravens. I'm going to convert this thing. I'm going to convert this thing into miles per hour. First, let's worry about the yards. 1 yard is 3 feet. Canceling out yards. There are 5,280 feet in 1 mile. Cancels out feet. Now I got miles. Miles per second. So 60 seconds is in 1 minute. And 60 minutes is in 1 hour. That cancels out minutes. This calculation, the bottom of your screen, will spit out miles per hour. I'm going to have to flip over to my calculator in a moment just to kind of do this calculation. But basically, I'm going to type in 80 divided by 9, and then I'm going to multiply by 3, and then I'm going to divide by 5280, and then I'm going to multiply by 60 and multiply by 60. Let's take a look. 80 divided by 9 times 3 divided by 5280, but you could technically type this all in at once, times 60 times 60. There we go. The man ran about 18.2 miles per hour. 18.2 miles per hour. Let me zoom out a little bit. There we go. That's what that problem would have in store. I love it. I love it so much. So not only is it understanding what the question is asking in terms of, he has to run 80 yards, but you have to do that conversion as well, because I would prefer miles per hour. In fact, I would have to change that wording on the actual final exam. Excellent. Okay. Let's see what else we got here. I want to do that one, but I might want to save that one for next week. Okay. I got 2 more problems I want to try. 2 more problems for today, and then I'm going to give you the remainder of the time to continue working on those projects. A basketball player who is 6.5 feet tall is at the free throw line. He shoots the ball at an angle of 70 degrees with an initial velocity of 20 miles per hour. What is the maximum height of the ball will be? Find what the maximum height of the ball will be. Now, there is something that you need for this particular problem. And it's a formula that we did in class. I'm going to write it down right underneath the words here, which you should already have this in your notes, but I'm going to give it to you anyway. Height equals negative 16t squared plus parentheses v sub 0 sine of theta parentheses t plus h sub 0. Zoom in a little bit on that. This formula, or equation, I should say, depending on the initial velocity, which in this case we know is 20 miles an hour, and the initial angle, which is sine of theta. Depending on what those two things are, is going to determine the height of the ball at any given time. Going to determine the height of the ball at any given time. Now, what's interesting about this particular formula, as we did in our notes, is we need to have the initial velocity actually expressed in feet per second. We need to have the initial velocity expressed in feet per second. Part of the reason, if you think about it, you're trying to find the maximum height. You're not going to be finding, the actual height in miles. You're going to be, it's a guy shooting a basketball, maximum height, and miles per hour. It's going to be, the t has to be measured in seconds. So one of the things is, or one of the addendums that I'm going to put down here, is that initial velocity needs to be in feet per second. And the height is already measured in feet, so we're good there. Once we convert that 20 miles an hour, we'll be able to create an equation. So 20 miles per hour, 1 hour is 60 minutes. 1 minute is 60 seconds. 1 mile is 5280 feet. That conversion has to take place. I'll just do that real quick right here for the sake of expediency. Boom. Should be about, and I'll move the paper over, 29.3 miles per hour. Oh, miles per hour. What am I talking about? Feet per second. I just did the conversion. It's 29.3 feet per second, as you can see right there. Now from here, I can plug everything into the formula. I'm going to leave it temporarily as what they are, what they're plugged in as. You'll see. So the height should be negative 16t squared plus parentheses 29.3 sine of 70 degrees t plus 6.5. Now this problem is going to require, we'll move that up a tiny bit. This problem is going to require a couple of things here, because this kind of combines a few different things that we've done over the course of this school year. By the way, just for the sake of argument, this problem, I'm going to finish up with this problem. I won't do the second problem simply because this problem does take a little bit more time and a little bit more involvement. So number one, we need that formula that I've given you in the past. We needed to convert initial velocity to feet per second, which we did right there. Plugged all of this junk into the calculator. But now the question is, okay, a basketball player who is 6.5 feet tall is at the free throw line. He shoots the ball at an initial angle of 70 degrees, with an initial velocity of 20 miles an hour, which we converted to be 29.3 feet per second. The question is, what is the maximum height of the ball? Well, in order to get the maximum height of the ball, this is a quadratic. We're going to need to calculate a vertex. This problem involves several different things that we've done over the course of this year. Conversions, using those formulas. And now dealing with quadratics. Negative b over 2a. Well, the b value, I'm going to put this into the calculator in a little bit, but the b value is actually 29.3 times sine of 70. Now, I don't know what that is at the moment, but I'm not going to worry about what that is at the moment. Instead, I'm going to have the calculator do it for me. I'm going to move that out of the glare. Don't worry. That down a little bit more. There we go. And on the bottom, I'm going to put a negative, well, technically, 2 times negative 16. I'm going to have the calculator do a lot of the rest of this stuff for me. So let's see what happens. Come on, calculator. Be my friend. I already set it to degrees, so hopefully I don't have to change it back. I mean, I don't know if you closed yours out. Clear that. No. Parentheses. Negative 29.3 times sine 70 degrees divided by, well, I'm just going to type in negative 32 because that's what the bottom of that fraction actually is. Excellent. 0.86 seconds. And that should make sense because obviously with a free throw, it only takes a fraction of a second for the ball to reach its maximum height. 0.86 seconds. And then in order to get this maximum height, I would have to plug all of that junk, or not all of that junk, but I would have to plug the 0.86 into the original formula. I'm going to show you what I wrote. Zoom out. Hopefully that glare is right in the middle. Trying to move the paper over. There we go. That should do it. You can calculate the x value of the vertex, negative b over 2a, 0.86 seconds. And then I'm going to take that 0.86 and I'm going to plug it back into the function. Let's see what happens. Again, this is the last question I'll do, and then I'll kind of review exactly what we did. Negative 16. Negative 16. 0.86 squared plus 29.3 sine of 70. Why did I do that? Every time. 7 degrees. 0.86 plus 6.5. There we go. I had to be very careful with how I did that. But that gives me 18.3 feet. Let me recap exactly what the heck just happened. Because this was a lot of stuff in one problem. Here's the initial issue. A basketball player who is 6.5 feet tall is at the free throw line. He shoots the ball at an angle of 70 degrees with an initial velocity of 20 miles an hour. Find what the maximum height of the ball would be. This formula for height is the formula that we would need in order to model this equation. We need to convert the 20 miles an hour into feet per second. That needs to happen because we're going to be measuring height in feet and we're going to be measuring time in seconds, especially with someone shooting a free throw. I plugged that information in for the initial velocity and for the angle of elevation. And from there, well, If they want to know the maximum height, then I need to find the vertex. To find the vertex, I'm using negative b over 2a. In order to calculate this thing out, I plugged all of that stuff in where it should go, and it spit out 0.86 seconds, which is how long it takes for the ball to reach its maximum height. In order to actually find the true maximum height, I would need to take that 0.86 seconds and plug it in for t into the original equation we came up with, and it spits out 18.3 feet. Which makes sense. With a free throw, you're kind of arcing the ball. You're already 6.5 feet tall, so that ball's going to go a bit higher than where you're standing. This would be like an open-ended problem that would have multiple parts to it that I would be grading. Multiple parts. Now, mind you, I would give you that formula. I am not expecting people to memorize this original formula that I gave you up here. I would not expect you to memorize that original formula. I would give you that original formula. I would give you the vertex formula. But it would be your job to kind of fill in the gaps. I would give you the tools, and then you would have to go from there. Okay. Now, like I said, I'm purposefully spreading out this exam review. I am. I'm purposely spreading it out. We started on Wednesday. We continued today. I'm going to continue on Wednesday, Friday of next week as well, because I don't want to throw all of this stuff at you at once. I want to revisit it gradually over the course of time. So with the time that we have remaining, which you have roughly 20 minutes or so, 25 minutes, I would like you to continue working on those projects, those unusual sports projects. And if you have any questions, of course, you can email me. I'm going to sign off on the live stream in a few moments. So if you have not commented in the chat, if you haven't already, please do that now, because I'm about to shut this thing down. But then, of course, you're taking the remaining time and working on that project. Like I said, the mid-project checks that I saw so far, I was very happy with them. I was very happy with them. Please make sure that if you haven't done that, you do that. But I'm going to sign off. Everyone watch the Ravens on Saturday. We're going to beat the Bills. And then we're going to face the Browns in the AFC Championship game. It's going to be hilarious. I really don't know what's going to happen. Actually, I do wish it were the Chiefs. We got to get past the Chiefs. Anyway, shut up. Yeah, I will see you guys next week. We'll see, maybe. All right. Bye-bye. 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 Bye-bye.